दो, माँ सरस्वती वरदान दो, मुझको नवल उत्थान दो, माँ सरस्वती वरदान दो। तू ज्ञान की सागर जो है मेरे, भर दे पावन दिल मेरा, ये प्रार्थना स्वीकार कर, मुझको नवल उठान दो, माँ सरस्वती वरदान दो।
Now it's time for the University Colgate.
महामना की सुयश शोभा, तकनीकी की यह तपस्थली, योग स्थली गुरु गोरक्ष की, बुद्ध की निर्वाण स्थली, महामना की सुयश शोभा। दृश्य अनुपम राबुदी का, मिलती गल रोहिणी वलय, ज्ञान मार्गी संत कबीरा की कृति हुई मनोहर मधुमय, ज्ञान और विज्ञान का मंदिर मनोरम शुभ्र पावन, शोध के जिज्ञासु करते सरस्वती का चरण वंदन, महामना की सुयश शोभा, तकनीकी की यह तपस्थली, योग स्थली गुरु गोरक्ष की, बुद्ध की निर्वाण स्थली, महामना की सुयश शोभा। मानवता का मंदिर मनोहर, आलोकमय दिव्य सुंदर, गूंजता परिसर हमारा, सकल विद्या का शंख स्वर, नवीनता की खोज में संलग्न यह विद्या सदन, सुज्ञान के इस कल्पतरु का करते हैं हम शशक नमन, महामना की सुयश शोभा, तकनीकी की यह तपस्थली, योग स्थली गुरु गोरक्ष की, बुद्ध की निर्वाण स्थली, महामना की सुयश शोभा।
Now I request Dr. Navdeep Singh to introduce about the course. Over to you, sir.
Okay, thank you, Ankriti. Good evening to all of you. On the behalf of Electrical Engineering Department, I warmly welcome our. Is it audible? Hello.
Yes, sir. Yes, sir. Is audible, sir.
Yes,
Yes, sir. Audible, sir.
Audible.
Okay. Okay. I warmly welcome our program patron, the Honorable Professor Vice Chancellor, and our team Chief Guest Professor Ramesh Bansal, Electrical Engineering Department, University of Sharjah, and Professor Ranjan Behra from IIT Patna. We also welcome our Chairperson and Head of the Department, Professor V.K. Giri sir, and Program Coordinator A.N. Tiwari sir, and a special welcome to our respected faculty member and participants. The Electrical Engineering Department at MUT Gorakhpur is organizing a 6-day faculty sponsored by AICT and conducted by the Electrical of Challenges of Autonomous and Electric Vehicle. The program will take place from January 27 to February 1, 2025 in online mode. The FDP will span 6 days with session held from 6 p.m. to 9 p.m. each day. A total of 13 sessions will be conducted, each lasting 1.5 hours. The objective of this program is merely focused to provide a fundamental knowledge on the challenges of autonomous and electric vehicle. This vision of the FDP is to empower faculty member and research scholar to achieve their goals in the field of electric vehicle, renewable energy integration, smart grid power management, green hydrogen and energy management, and so on. There are different topics which is covered by our resource person, which is related from the IITs and NITs and Central University and abroad university. We are honored to have the key speakers such as Professor Ranjan Kumar Behra, affiliated from IIT Patna. It will be taken in a session 2, which is focused on the advancement of power converter for a electrical vehicle system. Next session will be taken from the Santosh Kumar Singh, which is affiliated from the IIT BHU. Next is the Dr. Kuwar Aditya. It is affiliated from the IIT Jodhpur. And next program will be taken from the Vice Chancellor of the Chandigarh University, Professor Manpreet Singh Manna, and also is affiliated from the SLIDE Chandigarh Central University. Next, our program is focused on the what is the role of the fuel energy which is used in an electric vehicle. What is the challenges? It will be taken from the Dr. Sanjeet Kumar Dwivedi, which is affiliated from the industrial person, and it is related to Ever Fuel Denmark. Next session will be taken from the Dr. Rahul Dubey, Embedded AI, Duelis San Francisco. The main focus of this program, what is the role of the AI sensor? It is covered by the Rahul Dubey sir. Next session will be taken from the Bridge Ensing, which is affiliated from the John Deere, North Dakota, United States. He is focused on the what is the role of the battery management system, and what is the challenges which is related to the for the consumption of the battery utilization in a electric vehicle system. Next session will be taken from the IIT Bhilai, Professor Shailendra Kumar, affiliated from the IIT Bhilai. He will be focused on the role of the controller, which is focused to utilization of the role of the power management, battery management directly attached to the electric vehicle system. Next session will be taken from the Professor Ashish Kumar Singh, which is affiliated from the NIT Allahabad, and Arvind Kumar Singh, he is also attached from the NIT Allahabad. Last session will be taken from the two speaker Rakesh Maurya and NIT Surat, and Professor Vijay Pratap Singh from the REC Sonbhadra. So all the session will be taken from the IITs, NITs, and higher education system, which is related to empower the education system, which is imparted to the role of the electric vehicle system. These distinguished speaker will address topic like the latest advancement in autonomous vehicle technology, electric powertrain design, battery management system, and the integration of the renewable energy into the transportation ecosystem. This is the brief description of the ATAL AICT FDP. This FDP is sponsored by the AICT. All the candidate has to be registered from the AICT portal. Once again, welcome to the FDP. AICT system, which is directly sponsored this program, and we also look forward to an enriching experience together to gain the knowledge from these speakers. Thank you, Anukriti, and now extend your program. Send to the
Okay, sir.
next query for that.
Thank you, sir, for the brief introduction about the course. I now request Professor V.K. Giri, Chairman of this FDP and Head of the Electrical Engineering Department, Triple University, Gorakhpur, to please take over the virtual dais for the welcome speech. Giri sir.
Hello. Hello, am I audible?
Yes, sir.
Yes, sir. Audible.
Thank you, Anukriti. I think I have to be there in two capacity, one as a chairman of this FDP and another I am charge of that. Honorable Vice Chancellor is on leave, so I will be taking his space also in this. First of all, I would like to congratulate the coordinators of this FDP, Professor A.N. Tiwari and Dr. Navdeep Singh, for organizing such a FDP. And the topic which has been taken for this, that is challenges of autonomous and electric vehicle. So this is also very relevant. Before going to talk about this topic and this FDP, details has already been shared by Dr. Navdeep Singh ji. So let me introduce my university as well as the department before you, because the participants, I think around 100 participants have registered so far, and more than 80 is already connected online. So about Madan Mohan Malviya, it is one of the oldest college, and opened in 1962 the name of Madan Mohan Malviya Engineering College, and then later on in 2013 it has been upgraded to the university, and it is well known nowadays is MMM, University of Technology. This was the first technical university of Uttar Pradesh, and this has been this engineering college has started with the 3 branches, and then later on during the college 2 more branches has been added to this one, and presently in the university capacity we are having 12 departments. University is running in its full swing and in full mode, and we are having all the structure, infrastructure, the facilities, the hostel, the department, the labs, everything for all these 12 departments where the UG, PG and PhD programs are running. There are 12 PG programs, and almost all the departments, 12 departments, the PhD programs are also successfully running at present. I would like to share some of the achievements which we have received in recent past. That last year we in the engineering category and in NIRF we have got 84th rank. So this was the first time when we came under 100, and in university category we got 94th rank. So itself is sufficient to tell us. And in other category, that is state public university category, we got 40th place. So this, because these rankings are meant for that, so I need not to explain much about this one. The itself, because the assessment of this, the basic structure of assessment of this, take all the parameters, the different criteria, taking care of all these things, and that is how we have been ranked. And still we have got the place in the South Asian QS ranking also. Recently we have also got the first position in BBA department, the management study department. So these are our few achievements, remarkable achievements, which we have got last year. As far as this course is concerned, the electrical engineering department has been always the leader, leading from the front for this university side, and we always organize symposiums, international conferences, and these type of FDP. So in this capacity of the chairman and head of department of this prestigious department, I would like to tell you that we have got good number of faculties and they are doing well. And the PhD programs means we have got about 40 PhD students registered presently, apart from our PG and UG projects. So they all are working very sincerely. As far as this topic is concerned, normally I used to tell in my briefing in different sessions with the students that if you are working nowadays in the electrical engineering department, your obvious topic has to be either PV or EV, and this is one of that one. So, and I think all of you should agree, will agree with this fact that in your institute or wherever throughout the world, the focus is mainly on the either on PV or EV, and that is the need of our today's. So that is why this topic is well suited, because in the topic what is required is there must be a innovation, there must be a novelty, and there must be a sustainability picture. So all these three things has been taken care. I am also thankful to the AICT for sponsoring under this ATAL scheme, and this is the fifth program we are carrying out continuously. We are since 2022 we are regularly getting, and this time now earlier there was a method to give one program to each whoever is applying. Now little bit selection procedure is there, and fortunately we have got this program before you. So I hope that in this week, that is which is starting from January 27 to February 2025, this online mode. See, sometimes there has been this discussion that why it is being conducted in evening and this and that, but I appreciate this after a lot of the discussion. This timing has been found out, and this is very appropriate because most of us, of course, apart from day-to-day work, but this is the time, because if in the working hour, normal office working hour, we are having so many other things like our regular lectures and some other appointments, the official work, the administrative work and all. So that time on the participation wise, it is not easy to participate nowadays in offline mode because of the traveling and all these things. So this is the best mode of conducting the FDP, and I am 100% sure that the speakers, the eminent speakers, which has been introduced by Dr. Navdeep Singh, they all are very well qualified academicians, and they are the pioneer persons, the very good researchers, and their deliberations will be certainly helpful to all the participants and the researchers, their supervisors, as well as whoever is attending this program. They are going to be benefited by some way for their own project, for their own research. So with this, I once again welcome you and extend my best wishes to all of you for a successful conduction of this program. Thank you very much.
Thank you, sir, for your incredible work. Your blessing will always keep us motivated throughout the FDP. Now, I would request the Honorable Chief Guest of Inaugural Function, Professor R.C. Bansal, to please address the audience and shower the estimate blessing upon each of us. Professor R.C. Bansal, over to you.
Thank you all. So, am I audible?
Yes, sir, you are audible.
Yeah, it is
Yes,
a
sir.
great pleasure. It is a great pleasure to address briefly in the inauguration session on this faculty development program on this very important topic challenges for autonomous and electric vehicles being conducted in online mode for 1 week program organized by uh, Madan Mohan Malvi Institute of Technology, Gorakhpur, conducted by Department of Electrical Engineering. So the theme of this project in recent time extremely important. So it is a great time that when this electric vehicle is now coming up along with the renewable energy integration. So both go side by side. So the program has been designed very nicely. Uh, the coordinator of the program, particularly Dr. Navdeep Singh, who has been continuously interacting with me for several months, discussing about the program and the schedule. So the topics, it widely covers the topics, as introduced by Dr. Navdeep Singh, talking about the power electronics, battery for the electric vehicles, its environmental impacts, charging methods. So basically, the topics, broadly covers almost all the topics associated with the electric vehicles. And I am delighted to see that, when I joined, maybe, 5 minutes before the session, I just only saw that participants were around 40, but within few minutes, now you can see that participants are close to 125. So it is a great that, so many faculty members, researchers have the great interest in the topic, and they are joining. Many of you, as the head of the department mentioned, some are in the supervisory role for the researchers. Many of them are, PhD students who are attending as a faculty from the different university. So, in fact, it is a great pleasure to see that such an enriched program being conducted, and as we see the timing and the mode. So, which is like, in fact, a perfect, which it can be conducted in the online mode, and particularly in the evening when we just free from the normal teaching and work, and so that we can fully focus during office time. So it is very difficult to concentrate and focus on some additional things because of several other things going on. So this program sponsored by AICT, run by this Gorakhpur University of Technologies, particularly electrical department, very active. I recall few months earlier, I think the department conducted the international conference as well. So I see that department, is very active. The university is very active, and it's ranking continuously, visible, came around 80. So this is really great. So basically, I don't want to take much time in the inauguration session, but I wish the organizing committee, faculty of the electrical engineering department, the head of the department, and then the coordinators, Dr. Navdeep Singh, Professor Tiwari, another Professor Tiwari, I know him personally. So I know several faculty members from the department. So I wish all the best to the researchers, the participants who are attending the program, and I wish that this program is really very fruitful for this all. And I wish all the best and successful this program. Thank you all.
Thank you, sir, for your valuable work. Now I request Professor Ayan Tiwari, coordinator of this program, to please give a vote of thanks.
Thank you, Ankriti. It is really our pleasure to propose vote of thanks on the occasion of inaugural session of FDP on challenges of autonomous and electric vehicle. First of all, I will thank Professor Ramesh Bansal sir, Electrical Engineering Department, College of Engineering, University of Sharjah, who has provided his kind consent to conduct the inaugural session and with the inaugural lecture overview of electric vehicle technology. Now I will thank our Vice Chancellor in charge, Professor V.K. Giri, and our head of department, he is also our head of department, who spared his valuable time throughout the application to execution of the FDP. We really acknowledge his contribution. On behalf of our university, I thank and give due acknowledge to AICT Training and Learning Academy for sponsoring the online faculty development program. Now, I will thank to all faculty, resource person and participants for joining the program. Hope they will enjoy it and all sessions will be really useful. I will thank once to all again. Thank you very much.
Thank you, sir. Now we should begin the FDP with the first session. The first session of this FDP is on Overview of Electric Vehicle Technology by Professor R.C. Bansal. We honor to invite Professor Ramesh Bansal. Professor R.C. Bansal has more than 25 years of experience of scholarship of teaching and learning, research, industrial and academic leadership in several countries. Currently, he is working as a professor in the Department of Electrical and Computer Engineering at the University of Sharjah. Professor Bansal has published over 400 journal articles, presented papers at conferences, books, and chapters in books. He has Google citation of over 16,000 and HI index of 59. He has supervised 25 PhD students, 5 postdocs, and currently supervising several PhD students. His diversified research interests are in the area of renewable energy, wind, PV, microgrid, and a smart grid. It's such an honor for us to have today between us. Please welcome Professor Bansal, sir. Over to you, sir.
Okay, thank you all. So I will share the PPT. So share screen, right? It's not appearing yet, right?
Your skin is shared, but
yeah, let me see. Let me share. Then
at the topmost, you can see that there's share option.
Share a screen and then window. Window?
Yes, sir. Sir, screen. You can share your screen, entire screen.
Share screen.
Yes, sir.
So that's why I shared. Maybe.
Yeah. Now you open your. Yes, it's visible, sir. You can make it full screen.
Let's see. From where we. Can you see the options, please?
Yes, sir, it's visible. You can go through it.
Start.
Yeah, yes.
Okay. So, thank you all. So, I'll just briefly introduce the topic. So, I will just present on the general overview of the electric vehicle technology. Briefly, I will start with the general introduction and overview of electric vehicles, how we are shifting from the conventional vehicles based on the diesel or petrol to the hybrid electric vehicle or electric vehicles. Then I briefly briefly introduced some of the advantages of electric vehicles. Then I talked about the in general electric smart grid and the smart grid associated particularly with the electric vehicles. What are the components and features of electric vehicles, like in terms of motors, drives, energy storage systems, power electronic converters, and then its charging aspects, vehicle to the grid to the vehicles. So I just give very brief overview about these aspects. So first of all, like the general introduction, why in recent time worldwide we started talking about the electric vehicles. Like we worldwide we have been going well with this vehicles based on the petrol, diesel. So what is the major issue we see with this? Petrol, diesel. One of the big concern about the pollution, global warming that is being caused by this transport sector. So this issue, as we can see, this issue, the COP21 has targeted to achieve this global warming issue, that the warming below 2%. So governments around the worldwide they have initiated the various programs through like renewable energy integrations, electric vehicles to reduce the emissions, because this emission is badly affecting the this human life. So some of the countries like UK government has officially announced even to ban the new gasoline or diesel vehicles from 2030. So because of this concern, like UK government banned about the gas and diesel vehicle from 2030. So basically countries are coming up their policies how they can move towards the more sustainable and green types of electric vehicles which they expect in few years. Same way like the India has also committed to how this greenhouse gas can be reduced, say by 30% by 2030. So all countries are setting their targets that how they can reduce the greenhouse gas emission. So because of this pollution, so there are several health issues and concerns in terms of emissions coming out from the electric vehicles. Same way the emission coming out from the conventional power plants in terms of NOx, SOx, and there are so many issues which badly affect the health of the human being and vegetation. So we hear so many health issues, very common common problems which we are listening very frequently, for example, cancer and so many things. So which are, previously we hardly used to hear, but now so many, disease, health issues becoming so common. So because of several, environmental and pollution issues which badly affect the health of the human being, vegetations. So obviously we have to see the green and sustainable means of transportations, and of course power generation. So this is extremely important, and because of this global warming, we see that how the weather worldwide is changing. You might have heard last year that flood in Dubai. So which we never imagined. There is hardly any rain in the Dubai, but you see because of these different global warming issues like the Europe summer in Europe. So basically all these weather this global warming, several issues we are now noticing worldwide. So and of course these problems, whether it is related to the health issues, global warming, environmental issues, they will basically again relate with the economy, and they will shed back to the economy as well. So basically there's so many health issues, deaths being cause of these environmental issues. So this is like the big concern around the world. So in terms of transport sector, so you can see the estimated growth in the electric vehicles. So how the electric vehicles started growing, that it mainly started around 2015. So within 10 years, so getting quite popular. And we can expect maybe by end of these years, maybe worldwide, we may have, let's say, more than 8 million vehicles worldwide from the electric vehicles. So now electric vehicles have really started growing. We see that there are several manufacturers of electric vehicles, and it is starting appearing and increasing. So some of the concern what we see with related to the issues what we call as the environmental issues, some of the emissions aspect related with the these environmental issues. So basically the countries in which this, in fact, I examined maybe few years earlier one thesis, I think from the IIT Guwahati. So it was very nicely documented some of the countries, how we see the air quality index, some of these countries, big countries like China, India, US. So basically a lot of producer of the electricity energy, and then of course transport sectors. So they badly affect the air quality, which is really a great concern. Then in figure like on this right side, you can see that different sector from where this emission is being caused. So you can see the largest sector which is causing this emission, it is the electricity or power sector, which is one of the biggest sector that I will briefly talk, although we are talking more on these electric vehicles, but I will briefly talk about that. And then another sector which you can see like the transport sector, which is also quite significant, causing the emission. These two are you can say closely related as well. So when we have these electric vehicles, then obviously how these are charged, so you can say closely related with each other. then of course we have several other sectors which will depend upon these power industries as well. So in terms of like the land and forestry, agriculture, residential and commercial buildings, residential and commercial buildings. So this is giving little bit overview of that from the different sector, how this and global emission is being caused. Then, when we talk about the transport sector, then to see that, from the different kinds of transportation, talking about the rail transportation, sea transportation, air transportation, and finally the road transportation. So you can see that 80% of this, this emission is being caused from the road transport. So basically, major focus should be around this road transport. And then talking about this, when out of this road transport, you will see that different types of vehicles on the road, how they are divided, which are causing the emission. So like the buses, goods vehicles, then of course like these cars and jeep, and then of course you can see a little bit two-wheelers. So mainly you will see that buses, goods, cars and jeeps. So and then of course two-wheelers. So they mainly in terms of emissions, though they significantly cause the emission. Okay. Now, as I mentioned that these electric vehicles and then the power industry, they are closely related with each other. So let us talk about how much environment issues is being caused from the electricity sector. So these you can see some of the big countries, how much electricity is being produced, but at the same time, how much pollution is being caused because of the electricity generation through fossil fuels, coal-based. So huge amount of this emission is being caused in the electricity power sector because of the electricity generation from fossil fuels. Many countries worldwide have significant electricity generation from the coal-based power generation, like 50%, 60%. Some countries, like for example South Africa, which may have electricity generation from the coal-based more than 80%. So the huge amount of the emission is being caused because of this fossil fuel, and which badly affects the health of the human being and vegetations. Just to see that for example, how much emission will be caused, how much coal we will be burning in the different power plants. So this model I took from the book undergraduate level. So you can see this is a small scale model of 30 megawatt boiler, and then producing the electricity of 12 megawatt, efficiency being around 40%. So here in this small size coal-based power plant, how much will be the coal consumption? So coal consumption in this small size power plant, it is like the 1 kg per second. And if you want to find how much will be, the coal consumption for 1 day, so simply just multiplying, second converting to the, minutes, then hour, and then day. And so you can see how much coal will be needed. This I'm talking about the small 30 megawatt, boiler. think of that in our country, we are producing close to say 200 gigawatt of power from the coal-based power plant. Think of how much coal we will be burning on daily basis or annual basis, and how much emission it will cost. From this simple model, you can see that how much will be the air required, how much will be the steam produced, how much will be the quantity of the water needed for cooling purpose. So you can make a very good estimate. I give you example when in winter season, when during winter time we use this we in villages particularly people will burn the coal and then how much smoke it will cause, how much issues it will cause to the health issue. Just we are burning 2 kg 3 kg coal, how much issues it can cause. If the windows not properly open, it can lead to have several health issues. But we think of that when the huge amount of the coal is being burned, how much emission it will cause and how badly it will impact the health of the human being, vegetations. So it is beyond imagination. So Earth cannot afford to have further. And think of that, how many more years we can go ahead with the fossil fuel, coal, gas. So different estimate, 30 years, 50 years, 100 years, and then what's the next? So we obviously have to think the solution, which is green, sustainable, whether it is electricity sector. We are seeing this renewable energy integration in terms of wind, solar, photovoltaic systems, etc. And then, of course, in terms of transport, based on this like electric vehicle, then obviously we expect electric vehicle being charged through the renewable power systems. So this we talked about the issues, what we are seeing environmental issues, whether it is power sector or it is in this transport sector. So these two sectors very closely associated. So one of the big concern is environmental aspect, and then of course the detailed session will also be taken talking about discussing about the environmental issues for the electrical vehicles. Like in relation to this, you can see different types of fuel shares being used for electricity generation. So coal is of course declining because of the reason I mentioned. And you can see that combined hydro and nuclear, so they're also little declining because the large hydro sites worldwide have already been harnessed in most of the countries. Gas use is quite stabilized. The worldwide main interest is towards the renewable power integrations. So current share worldwide for the renewable power integration would be around say 15%, not more than 15%. But of course, if we include the large hydro, then its share will be obviously significant. But when we are talking about the small scale integration, so its share is around 15%. Then generally many people will talk that when we have these electric vehicles, whether it is being and then of course renewable power integrations, when it completes its cycle maybe say within 20 years, then the waste being caused by that. So whether renewable power plants or electric vehicles, they are really renewable, sustainable, green. So like one of these report you can see here. So published. So if we compare the waste coming out from the different stuff like municipal waste, And this is like say year starting from 2016 going until 2050. The waste coming out from these municipal waste, you can see this size compared to the waste coming out from the coal-based power plant, and then you compare the wastes like the plastic, and then if you compare the waste coming out from this like renewable PV modules or batteries or electric vehicles, so you can see that the waste coming out from the these renewables or these battery storage systems, so it will be significantly very small. Now, how this modern cars, the paradigm is shifting. Okay, so we have seen these days that internal combustion engine vehicles, what we're talking about, the vehicles based on the petrol, diesel, and then we show the shift few years earlier, like in our country, gas based electric vehicles, we saw like in the cities, Delhi, when these autos taking the gas from the CNG, compressed natural gas, so which considered to be quite green, that phase we saw. So it comparatively reduced the emissions. But now in recent few years, we are talking about the hybrid electric vehicles. So the vehicles which are based on the this petrol, diesel, if they can have the hybrid in terms of petrol, diesel, and then electric vehicles. Then now we are talking about specifically purely electric vehicles. So these are some of the stages, the shift from the internal combustion engine vehicles to going for the advanced electric vehicles drive. So this is some of the changes, steps what we are going to see in the transport sector. So when we see some of the characteristics of like these battery electric vehicles, hybrid electric vehicles, or fuel cells based vehicle systems, particularly seeing or comparing, particularly with respect of these battery electric vehicles or hybrid electric vehicles, in terms of like the propulsions, energy storage system. So in electric vehicles, it is the electric motors, whereas in case of hybrid, it is like electric motors and IC engines. The energy storage systems could be in terms of like the batteries, capacitors, supercapacitors. In hybrid, it could be batteries, supercapacitors. Then it could be fossil fuels, petrol, diesel. And the energy sources, infrastructures. So in terms of electric grid, charging facilities. Here, obviously, gasoline, electric grid. Talking about some of the characteristics with respect of this battery electric vehicle, it says that zero local vehicles where you are charging the batteries. Even it is through the electric grid, locally it will have this almost no emission, but we have to see that somewhere this emission will occur if these electric vehicles are being charged through the conventional power plants. So aim and objective is to charge the electric vehicles through renewables power plants, like based on the photovoltaics, so that they don't cause the emission almost not at all. So they have the characteristics in terms of like the high energy efficiency, independent of fossil fuels. Generally, the range is one of the concern with the electric vehicles. Can be more costly. And then now getting available commercially. Then here in terms of like hybrid electric vehicles, there is local emissions, fuel consumption, generally comparatively have the longer drive range, but they depend heavily on the fossil fuels, and the cost of the fuel, is really going very, very high, close to 100 rupees per liter. So, quite costly. Then some of the issues when we talk about these, like, major issues, like when we talk about the battery operated electric vehicles, because the technology is quite new. So here the issue is what we see around the battery sizing and management. So this is like one of the major issue challenge. Then of course, charging facilities. Charging is one of the charging and infrastructure. So this is one of the big concern at the moment. And then of course, high cost and the battery lifetime. So these are some of the major issues. When you talk about the hybrid electric vehicles, again, like the battery sizing management, control optimization management. So these are some of the challenges what we see. Then of course, like, some of the key advantages what we can say with the electric vehicles. So you see that basically the electric vehicles, electric machines have high efficiency compared to internal combustion engines. Then of course they have a low level of environmental issues, so which will obviously improve the air quality. So this is one of the great advantages what we have with the electric vehicles. That's why we are moving towards the electrical vehicle from the petrol or diesel based gas vehicles. And then obviously you see that their operation is quite silent, so they have lower noise. Generally, you can see that maybe operation could be smoother. And these electric vehicles can be charged from the renewables, such as like these solar, wind, large hydro, even nuclear. So that will be really great. So that will reduce the emission, neither local nor remote. And then of course, like the energy storage systems in terms of batteries, supercapacitor flywheels, hydrogen fuel cells. So there are several storage options coming up for the electric vehicles. So talking about the little bit about the overview of the smart grid. So when we talk about the smart grid, of course, we have the electricity generation currently, both from the conventional power plants, even the coal-based, to meet the power requirements. Coal, we use almost all types of electricity generation: coal, gas, nuclear, large hydro. Then obviously there is more emphasis on this renewable power integration, say in terms of wind power turbines, photovoltaic systems, battery storage systems, even battery storage system being used in the renewable hybrid power systems. Battery storage system is needed in the electric vehicles, even for electricity generation. So even to generate the electricity, we can use the batteries. So we are talking about the different sizing of the batteries in terms of megawatt capacity as well. Then of course, like say residential buildings, commercial building, how we utilize the electricity energy. So we are talking about the net zero buildings. So how efficiently we utilize the energy. So all these forms the smart grid. So in the smart grid, the electric vehicle is one of the key aspects that we started discussing in recent time. So if we see that the what are the sub parts of the smart grid, so mainly it can be divided into the three sub parts. The one is the infrastructure. In infrastructure, we have got the infrastructure in terms of like how we generate the electricity, generate, transmit, and distribute through the conventional power plant. But in recent time, we started talking about the power generation through renewables. More recently, we have started talking about the electric vehicles, how these electric vehicles will be charged, and we started talking about the vehicle to the grid to the vehicles. Then the smart information systems in terms of the smart meters, phasor measurement units, sensors, etc. How there is a smart communication system. Okay, when we talk about the vehicle to the grid to the vehicle, so obviously it will depend upon what is the status of the battery, and to know the battery status, of course, in a vehicle there should be smart communication system, wireless communication system. Then how this smart grid will be managed? It will have several management objectives in terms of reduction of emission, reduction of cost, reduction of the price, and how this smart grid will be managed through these various tools, techniques, programming, conventional programming, linear programming, integer programming, recent technologies in terms of machine learning, PSO, and so many aspects are there for the optimization tools, techniques. And then finally we talk about the protection systems for the smart grid, how this smart grid will be protected, how the security and privacy of the data will be managed. So these are the sub parts of the smart grid. So when we talk about the smart grid, so the smart grid is not a complete replacement of the existing grid, but to complement the features with features like we need to have the centralized generation, but more emphasis on the distributed generation, to have integration of more and more renewable energy. Electric vehicles have become the extremely important part of the smart grid. That's what we are talking. And then along with that, the energy storage systems, whether we are talking about the renewable energy or we are talking about the electric vehicles. So in that, energy storage systems becomes extremely important aspect. Phasor measurement units to maintain the health of the transmission line, to measure to see in the real-time systems the health of the transmission system. Phasor measurement units extremely important. Then of course smart meters to manage our power system. Smart meters are extremely important for the metering of the energy, how much energy is being generated, consumed, whether there is any mismatch, misuse of the electricity. So only the smart meters can try to avoid these issues. Then of course, whatever we have the capitals assets in terms of cables, transformers in the power system, even the vehicles. So how we can make use of IT to optimize capital assets, reduce the operation and maintenance cost. Like when any vehicle will be replaced, so we can make use of IT to forecast the status health of these vehicles, when the maintenance to be done, reduce the operation and maintenance cost. So basically, how we are moving from the conventional grid to the smart grid, we need the centralized generation, but more emphasis on the renewable integrations. Then electric vehicles are now reality. Electric vehicles have come, and it will suddenly start growing. With this integration, obviously power flow becomes bidirectional. So through the smart meters, uh, customers can communicate to the utility. Utility obviously communicate to the customers through these smart meters. These smart grid have the property of these self-monitoring and self-filling. And at the end, whether it is conventional grid or the smart grid, which way at the end customers get benefits. So in the smart grid, it is expected that the customers have several choice. There is no more monopoly, and the customer can get the electricity at the affordable price, and of course, the quality of service. So as we are seeing that electric vehicle, there is a shift from the conventional vehicle to the hybrid electric vehicles, and finally going through the plug-in vehicles, and this is now growing rapidly worldwide. And obviously, we expect that there will be a sustained market share growth in long term. So basically, the economic issues and performance improvements, such as environmental issues, will improve. Energy security concerns. So these are the important driving forces, and many electrical engineering-based technology have this come forward in this direction. So when we talk about this, like electric vehicles, it's sub-components, sub-technologies. So basically, most of these will be discussed in this FDP in detail. So this technology, when we are talking about these electric vehicles, we talk obviously about the power electronics. So there will be, I think, 2 sessions talking about the power electronics. Then what are the options we have for the motor drives, electrical machines, advanced electromechanical powertrains, system integrations, vehicle controllers, electronic control units, energy storage systems for the electric vehicles, the controls, then the battery, hybrid battery, or ultra capacitor energy storage systems for the electric vehicles. And when we have these electric vehicles being charged from the grid, so we are drawing power from the grid, but we can feed back power into the grid. So vehicle to the grid to the vehicles. So this electric vehicles basically is like a modern transport car that challenges the current energy crisis and pollution issues. Beside the system implementation of the current vehicle requires efficient equipment to handle the functional features and meet the transportation drives. So here the electric motors and energy storage systems are the very much essential equipment to be coordinated for the efficient operation of electric vehicles. So electric motors and storage systems. So these are very important equipment to be coordinated for the efficient operations. And then of course, power electronic device assistant in converting the improving the electric cars functions. Moreover, these new electric vehicles can be connected to electric network to support the power grid supply. So the electric vehicle can supply power back to the grid as well. So various features of electric vehicles, including propulsion, storage systems, energy storage infrastructure, have and have these aspects. And then, of course, electric grid charging facilitates the electric vehicle integration to the power grid. So, this talking about some of the components like the electric motors. So, in electric motors, and then of course, energy storage systems in terms of batteries, supercapacitors. Some of the features like the commercially available high energy efficiency. They have concern about the higher cost. Of course, they are independent of the fossil fuels. And there is zero local emissions, so there are several advantages. These electric vehicles can charge through the electric grids, but the main objective that these electric vehicles should be charged through these renewable energy sources as far as possible. Even these customers are encouraged to have their own photovoltaic systems. Governments encourage to have, the PV system. There is rebate and government support on these photovoltaic systems. But there are some issues as we see for the electric vehicles in terms of battery lifetime, battery sizing and management, its maintenance, charging facilities, and overall cost, as this is comparatively new technology. So we think it takes time to develop the technology to the next level. So one of the issues what we see is the charging. So basically, this I took from one of the PhD theses I examined from MIT Jaipur in few years earlier. So here you can see that different type of charging what we call as the level 1, level 2, level 3. So in level 1 and level 2, what we call as that, it can take in residential, for example, level 1, around 17 hours. So which are basically like the voltage, which could be 120 like in US system, or like 230 volts. The current is quite low, around 15 amps. Or in terms of level 2, current can go higher. So in which the time could be reduced to say half, 8 hours. But when we are talking about the public charging stations, based on the voltage, like say 300 to 600 volt DC, and current, it can go up to 400 amps. So in which the fast charging, what we are talking about, vehicle can be charged in about 30 minutes of time. But sometimes in metro cities, like, people cannot afford to have, this 30 minutes of the, charging. Like we have seen in the past, like in Delhi, when we had this, the CNG based, these auto rickshaws. So like long queue. So it's really, very much irritating. So the charging. So now, like these 30 minutes of charging fast, or even like one of my, master student, this working on the research, talking about the battery swapping technology. Like, there will be stations, battery stations. You are, empty battery you can replace by the new battery. So it can be very fast. Of course, there can be several other concerns and issues. So basically, one of the great concern at this stage, we see that when electric vehicles have to come, so infrastructure has to be developed in terms of like the charging station extremely important. So this a great infrastructure has to be developed. for the fast progress of the electric vehicles. So this is very much important. Even I give you example that now here at University of Sharjah I see several electric vehicles. One of the colleague in one of the engineering department, he had his he has one car, then he bought his electric vehicles. So in the university parking there is one or two in this the charging ports. Then same way one or two more charging ports for the charging of small kind of golf carts. So he was trying to charge electric vehicle, but he find it very very challenging. So basically it may appear that just for some fancy or show off there could be few charging steps, but some of them working, not working. Even how they will put the cost for that. So there are several concerns, particularly about the charging stations, infrastructures. So this is like one of the key aspects that has to be considered, talking about the charging for these electric vehicles. Then in terms of drives, motors, what options we have got with respect of the motors. So we have got several options for the motors in terms of like based on this AC. We have the motors based on this what we call as the induction motors. Then these synchronous motors, permanent magnet synchronous motors. Induction motor, as you know, we can have this squirrel cage or wound induction motor. And then on these other options in terms of brushless DC motors, reluctance motors, DC fed motors. So we have got several options on the motor. In fact, one of my postdoc wrote one of nice paper. So I think it is coming. This slide coming from there. I will show the reference at then. So we have the different options for the motor. Which type of motor can be suitable for the electric vehicles. So need to be considered as well. Then how these electric vehicles will be charged. So mainly electric vehicles transport sector, based on the electric vehicle, it basically start growing because of the main concern of this emission. So if we charge electric vehicle through the conventional energy sources, so story is more or less same, whether we are just shifting the emissions from the local to the remote. So the emphasis currently is that at the same time we adopt a renewable energy policy as well, so that these electric vehicles mainly charged through renewables, like based on this photovoltaic systems. So this is extremely important. So we don't put too much pressure on our the conventional power plants. Already they are causing the huge emissions. So this is one of the important aspects. Then of course we need to consider that in coming few years it is expected that electric vehicles will grow exponentially. So into impact how much more load they are going to put on the grid. So we have to get prepared for that, expansion of the electric grid as well. So these are, some of the these aspects, and then of course talking about the storage systems, battery technology for the electric vehicles. So in fact, the battery technology is growing very, very fast. So we can have, several options for the batteries: lead acid batteries, lithium ion batteries, nickel metal hydrogen batteries. So we have large number of options for the batteries. So obviously, there are concerned with the different types of batteries, like the lead acid, like the generally have the drawback for the low energy and power densities, high maintenance requirements, short cycle, short issues like that. But they have also some advantages as well: reliable, the technical maturity. Then other options like the lithium ions have the drawback, like in terms of high manufacturing cost, etc. And then at the same time they offer some advantages like the excellent life cycle performance, fast charging capabilities. So different batteries offer several advantages, disadvantages. So we need to see what would be, the quite suitable battery technology. So this battery technology, like one of the very important aspect, and which needs the continuous efforts for the developers. Then of course, like you can have some other options in terms of ultra capacitors as the options. So then of course talking about the power electronic converters for the charging of electric vehicles. So the next section will be taken by Dr. Ranjan Behra, so who is a really expert in this area. I hope he will be covering. So you can see that there are so many options available for these converters topologies, and I think this will be covered in detail in some other sessions as well. So I'm not going into this detail of that. Then, like say, how we are charging these electric vehicles. We say vehicle to the grid to the vehicle, but it can be in general. Like one of my researcher wrote his research paper, so he says like vehicle to X could be anything. So electric vehicle connected to a power network is developed using the electric vehicle to X concept, where X represents any energy source that can supply to electric car. So this is a platform that can be used, the concept. So here figure 2 in this figure in the next slide will show that vehicle to X that can be used in this smart grid environment. Vehicle to H could be home, not only necessarily grid. Like from electric vehicle, you are powering to the home. Electric vehicle to the grid. So vehicle to the building. So controlled vehicle to the load. Vehicle to the microgrid. Vehicle to the vehicle. So you can have the different options. So which in general could be called as the vehicle to the X concept. So this basically here it is explained in little bit in detail. So I'm not going into the detail of this. Vehicle to the building, vehicle to the home, vehicle to the grid, vehicle to the load, etc. So this is simple stuff. You can see this charging of the electric vehicles from the power grid. So vehicle can be charged through this power grid. Even it can feed power back to the grid as well. And then you can have some other way. Then you can see these and other things like the wired charging system. And a recent time we also started talking about these wireless charging systems. So the technologies are being developed for these wireless charging systems as well. So I think most of the things I try to give an overview, and I have supervised large number of researchers in several countries in the area of renewable power integration, power system, distributed generations. So the researchers have contributed significantly in my research in terms of books, research papers. And then this is a recent book talking about the power electronics drive advanced applications. It includes the chapter like this co-authored by Dr. Behra. So we'll be having the next section. So significantly contributed in this book several chapters about the power electronics, electric vehicles. So contributed by Dr. Behra, who is really expert in this area. So there are some of the references in this book I mentioned. Then there is very nice, very recent paper talking about the impact of electric vehicle on the smart grid under various loading conditions. Then little bit old but very important, we can see energy storage systems for automotive applications. Then I supervise one master students from the University of Pretoria. The students studied about the battery electric vehicle charging, a case study in South Africa. So you'll find this thesis I examined talking about these electric vehicles, modeling and performance of lithium-ion batteries, electric vehicles, MNIT Jaipur, integration of electric vehicles in the distribution systems. Examine another thesis, state of charging estimations for electric vehicles, bridge planning. So I have examined several theses as well, and then some research papers you can see, for example, talking about the optimal sizing, placement of distributed generations, capacitor banks, electric vehicle charging stations. So I briefly gave an overview of the electric vehicle technology, covering some of the topics like the batteries, the development of infrastructure in terms of the charging stations, slow, fast, battery swapping technology, and then and then of course the charging, wired charging, wireless charging. When we have large number of electric vehicles, how it is going to have impact on the grid. So I just like to stop here, like to thank you all for your kind attention, and I will be happy to to respond to some of the queries. So I kept some time for some general discussion or some queries. I would like to again thank you all participants for your great interest. And then, of course, if there are any queries, so I'm happy to respond or reply. So thank you, organizing committee for sending me invitations for this very important FDP program. So wish you all the best. Thank you all. So please, if there are some queries, questions, more than happy to respond.
Thank you, sir, for an amazing lecture on this topic. Now, I request to participants to ask any query if you have, or you can write in the chat box also. So please, any query from the participant side?
Good evening. Sir, good evening. I'm audible.
Good evening. Please, when you ask, please introduce yourself. You are faculty researchers from which university? So please, little bit introduce yourself. So basically, this faculty development program, it is not only just development of technically, but the networking from the faculty researchers within country globally. It is extremely important. So, of course, you are welcome to contact me at later stages as well. So please ask your queries.
Thank you for this nice lecture. The PPTs were very useful for me. And my name is Amit Sharma. I am the research scholar from Madan Mohan Malviya. And sir, my question is that most of the countries are working on the EV, but I think most of the companies are not producing the EV because they are switching on to the hydrogen-based fuel.
Yes. Yeah. So yeah.
Recent example, Toyota, sir, that company has totally planned that he is not going to produce any more EVs, and that company is going to work on the hydrogen-based fuel because they feel that in the coming era, the hydrogen will be the only responsible for the transportation. So they are only switching on that. So how we can say that the electric vehicle is going to be very much impactful in the coming era? In that case.
Yeah. So this is very interesting question, and in fact, like say you can say hydrogen another alternative coming. So like say I'm not expertise on this hydrogen, and I don't have much experience about the hydrogen. But recently there was one professor from the Europe, Elberg University. So he's the editor-in-chief of this Elsewhere Energy Journal as well. So I think last year he was visiting and he gave the lecture, and then he compared these electric vehicles with respect to hydrogen. So what was his the conclusion from his talk that hydrogen at this stage is not feasible at all. So is not something what you can say sustainable or cost competitive with respect of electric vehicles. Basically, it is a new technology. So it is going to take time. At this stage, it may not be cost effective or compete with the electric vehicles. So it will take maybe another great research, or maybe say another next 10 years. So when it may be competitive. So at this stage, like there is time for the electric vehicle. So basically, the industry should not feel that hydrogen is coming. That's why we should not focus on electric vehicle. But electric vehicle again very closely related with the power sector. Anyway, we are using the transport sector, causing the huge emissions, and then we are just trying to replace or modify this existing transport sector to reduce the emission as far as possible. So I hope my response is a little bit clear to you.
Yes, sir. Thank you, sir. Thank you so much.
Thank you much.
Any other question from the participant side?
Good evening, sir.
Good evening.
This is Dr. Pushkar Tripathi from Institute of Engineering and Technology, Lucknow. Sir, my query was, sir, in what is major differences in electric vehicle scenario in Sharjah as compared to India? What, because you can give us practical insight, and what is future ahead for India?
Yeah, like say this, our country, really very big, very diversified, and progressing really, what I can say, in excellent manner. So comparatively, this UAE is small country, so we see that some vehicles coming up, but again, there has to be, there needs to have, big initiative from the governments to develop the infrastructure, because government, unless they develop the by sustainable means of these charging stations. So as the government support is must, and the worldwide governments are very, very supportive, because one of the biggest concern is about this global warming, the environmental issues coming about these two closely related sectors, renewable energy sector and the transport sector. So the electric vehicles is appears to be one of the great solutions to reduce the emission level, along with the renewable power integration.
Thank you, sir.
Thank you much.
Sir, there's a question from participant sides in the chat
Yes,
box. That's Samlind Banerjee. He has asked that, is there any scope of live polymer battery in the field of EVs?
So, Dr. Banerjee, research scholar. Yes. So basically, it is a great question. Like you see that there is very fast development in the battery technology. So many new batteries are coming up. Even you list down, maybe it could be reach close to 10. So possible options. So basically, the research is expanding very fast in the battery technology. So I'm not very much aware of these too much in the battery technology, but obviously, none of the battery technology appears to be, you can say, the perfect, because you see there are different factors to be compared: cost, charging, discharging cycle, its weight, power density. So if the battery, the research goes well and it is competitive, so it can be certainly a great candidate in future as well.
Thank you, sir. Sir, there is one more question.
Yeah, from Vijay.
Is from Vinay K. Vinay BK.
Vinay BK. So
Yes,
Vinay, MIT Manipal. So one of my favorite university. I supervised my first PhD candidate from there. Dr. Girdhar Kindi, now he is the registrar of their MIT Manipal. So basically, the converter, which converter is good? I showed you the different converter topology. and I am not very much expert in the power. So keep this question maybe for the next section, Dr. Behra, who is really the expert in the power, and we have this book talking about this power electronics. If you need any further reference, I will be more than happy to provide it. Then there is a question from Archana Moria.
Maurya, sir.
Yes, sir. So we are talking about the EV connecting to the grid, but it is going to affect the power quality and other factors of the grid power. Is there any option to deal with that? So this is like very good question in fact, and we afraid that when we have these electric vehicles being connected to the grid. Few years earlier, we used to have the same concern when the renewable power plants connected to their grid, they will also affect the quality of power supply. So in fact, like how this, the what we call as this grid code in case of power sector, or these regulations are there in practice, how strictly they are implemented. The power quality will basically depend upon that. So when the grid codes or these the guidelines, if they are strictly implemented and followed, and then there is no reason that it will affect the quality of supply. In fact, it can improve the power quality, because like one of the object when we talk about the electric vehicle to the grid to the electric vehicle, when there is shortage of power supply during the peak condition, so then in that case the electric vehicle can supply power back to the grid, so they can support the grid, they can improve the stability of the power grid. So rather than affecting the grid, they can support the grid as well. Yeah, so then there is question from Akhilesh Kumar Mishra. So it says that from BITS planning. So challenges in battery swapping. So it is not in like the Indian scenario, but it will be challenging globally. But this is like one of the possible solution, and things can be moved forward. So along with the fast charging technology, if someone is in very hurry, so there can be option along with the fast charging station for the battery swapping technology to reduce the waiting time. So things can be worked out, and this can also be possibly work as well. Let me see the next question. Maybe I cannot really read it. Can you please read the question from the... Yes, I can see that. So Khushi Shukla. My name is Khushi Shukla, BTech from Gorakhpur. I want to ask that which of these batteries this mouse is the best for the use of electric vehicle in practical life, which has the best performance. So there are some options. So you cannot say only this will be the best, because you see we compare several factors: technical and economical, cost, maintenance, charge, discharge, weight, energy density. So we compare at least 8 or 10 different factors, and then of course even mileage. So many factors we compare. So depending upon some situations, there could be like say from this all the options available, we short down to say maybe 2 or 3 options. So depending upon situation, we can say that, out of these 2, 3, this could be the potential good candidate for the batteries. But just saying that this will be the best the storage technology, meeting all these technical and economical aspect, that this is only solution. So very difficult.
Thank you, sir, for
Thank you much.
clearing all the queries from the participant side. I think there is no more query.
Are there some more queries from the participants? Please feel free to ask. So still we are on the right time. We are on the right time. So if there are some more queries, please, anyone want to speak with me, you are more than welcome. Welcome.
Hello, sir. Hello, sir. It is audible. So, sir,
Yes, audible.
Sir, my name is Dr. Vijit Kumar. Actually, I'm just working in the Parallel University right now, and I just completed my PhD from NIT Hamirpur. So now
Nice.
my question is basically what, sir? It is a general thing is there. What are the factors that basically impact the EV range? What are the factors that impact the EV range basically?
Yeah, EV range, like say you see that we have this the battery sizing, battery capacity, that when fully charged, when fully charged, how many kilometers we can go, and then there are different battery technologies, so there might be some varying options, and little bit its use, the condition of the batteries. So these some of the factors we see that, but of course, like we expect, that this is one of the concern, particularly for the long drive, that its short range is little bit a concern. That's why sometimes when we have frequent this long drive, then in that case maybe the hybrid option can appear to be even better solution as well.
Thank you, sir. Any more queries?
Sir, namaskar.
Namaskar. Ranjay Dhiraji, Hare Krishna, sir.
Hare Krishna.
So very nice to see you, Hare Krishna, sir. So in next session is yours. You are the expert, and you contributed heavily on this book, Power Electronics, Drive Electric Vehicles. And so this is very nice to see you.
अभी चेन्नई में IIT चेन्नई.
You are in IIT Chennai. Very nice, sir.
Meeting today, so I came yesterday.
Very nice, sir. How are you, sir?
I'm good, sir. बहुत दिन
Very
के
nice.
बाद देखे हैं आपको.
Very nice, sir. So yeah, you make so much of contribution. You with your busy schedule, you are moving so many places. So many places.
Sir, मेरा एक question था. Sir.
Yes, please.
I have one question.
Yes, please.
In the electrical vehicle and grid, that transition, what are the challenges when we really large number of vehicles connect, or the battery of 1 megawatt hour capacity if we connect to the grid for interchanging of this? So what are the main things we need to take care of?
Yeah, main challenge, at this stage, we have to, first thing is that regarding the planning, we have to forecast that, how the growth will be there for these electric vehicles. Like in 5 years, how many millions vehicle we will have, or how many vehicles we will have, then how the growth of the vehicle will be there, how much load it will be there on the grid. In fact, one of my master student in the UAE did the study that how this electric vehicle will impact on the grid, that how much load it will increase. So obviously there needs to be planning that this electric vehicle will be charged through this power grid. So the appropriate planning as the electric vehicles expand, same way power grid has to expand the capacity, particularly renewable energy integration should ideally expand in the same proportionate to cover up the load from the electric vehicles. So it needs extremely important planning technology. Then of course development of the infrastructure, charging stations, slow, fast. What are the different options for the people charging at the home when people are work, if needed charging, and same time options for supplying power back into the grid. If the people supply power to the grid, what way the revenue is given back to them. And then of course this various charging options, slow, fast, infrastructure development. So all these this is new technology. There are several concerns like the manufacturers. What are the different manufacturers? The cost of the electric vehicle. Like I was mentioning, one of my colleagues here at University of Sharjah. So there are the options like this vehicle from US, or there are some Chinese vehicles, so which are completely very low cost. So again, need to see this the affordability of the electric vehicles, their cost, maintenance as well. So there are several concerns, and it will take some time to get it developed to the next level. More, it's just like you can say kind of start. So maybe say next 5 years, 10 years, hopefully it comes to the next thing.
Thank you, sir.
Thank you very much. So thank you all. I wish you all the best to all the participants, organizers. Please plan to visit who have not been there to Kumbh. So this is very important. So thank you all. Wish you all the best.
Thank you, sir.
Thank you all. Thank you all. Wish you all the best. So please continue with this next session.
Okay. Thank you, sir. Thank you so much.
Thank you.
Hare Krishna, sir.
Hare Krishna, Hare Krishna, Hare Krishna.
The next session on this FDP is the power electronics technology for renewable energy application by Professor Ranjan Kumar Behra. Professor Ranjan Kumar Behra received a BE degree in electrical engineering from the Regional Engineering College, Raulkela, and the MTech and PhD degree from IIT Kanpur. He is currently an associate professor at the Department of Electrical Engineering, IIT Patna. His research interests include nonlinear control theory, application to power electronics converter, first with modulation technique, and a multi-phase electric drive control. He was a recipient of 2022 IEEE Outstanding Power Paper Award for the IEEE Transaction and Industrial Economics. Please welcome Professor Bansal, Professor Sir. Thank you, sir. Over
Thank
to you, sir. You can share your slide.
Yes, I am doing that. Is it visible now?
Yes, sir. It's visible.
Okay. So, good evening to everyone. So, today I will discuss a little bit about advanced power converter control for grid integrated solar system. So, this is already explained, madam, that my journey started from BTech at REC. Now it is NIT Rourkela. And through many travel other place, then finally in IIT Patna. So the research interests include solar, wind, power system, electric vehicle, and whatever related areas. And also we in Bihar many projects we implement. And many research activities which include wireless power transfer, smart grid, EV design, a pump system design, smart home, everything we do. So we also published 2 books and textbook. And many technology which we develop, we also display many places around the India technology. And this is my group where we work for product development. So this is a small electric vehicle where we have developed, and we have around 5 crore funding for this to develop this foldable electric vehicle. It is less than a small suitcase.
Excuse me.
This is completely designed. And now new version also 2, 3.
Excuse me.
Yes.
It's not audible clearly, sir.
Audio is not there, please. Anybody can do needful.
Yeah.
Audio, is it audible or not?
Not clearly.
Not clearly.
It is audible, sir. It is audible.
It is audible, sir.
Yes.
Maybe network issue is there, but it is audible, clearly audible.
Now is it audible?
Yes, sir, it is audible.
Okay.
Yes, sir, it is audible.
Okay. So anyway, this is one of the development. We got around 5 crore for this development. So many electric vehicle we developed, and recently we have developed one EV, which many people are attracted. And this is one of the 3-wheeler we developed. And there are other lot of products we develop in the laboratory. And the most important thing today we will discuss not an electric vehicle, but an grid integrated solar system, and especially installation part we will discuss more. So when we want to connect a solar system to the grid, there are many ways. And one is a DC system, one is the AC system. When your solar power is yielding more, then we want to integrate with the grid. So this is one of our lab where we developed a nearly 50 kilowatt power you can feed to the grid. You can see here there are multi-control system, a space controller with all this grid. We integrate with the grid. And below is the LC filters are there, and this is very complex structure we are feeding around 15 kilowatt load. So many times, generally when we feed the power from a solar panel or PV array, so you need to connect a converter which convert from DC to AC. And then the AC is because you have an inverter. Inverter, you will never get a pure sine wave, or you will never get a pure sine wave voltage or current. So what do we do? You need a filter. So we get a raw power from the solar, and like you get a raw water. So you need to have filtered this, then utilize. Same way, here also exactly we want to filter out, then feed to the grid. So how to feed to the grid? There are many ways. Like many people, they publish a lot of papers. When I ask in the interview, many people in their interview, sir, you have published many papers. Like in this year, in the Power Grid Award. So I was also one of the review member. Member. So for award committee member. So I asked many people that you have published many papers. How the power is transferred from the solar to the grid. And although they published many papers, it is very difficult for them to understand to reply this. A simple concept, like you study KVL, KCL, all these things, and a water flows. For example, if the water is at a very high.
Excuse me, sir. Sir, voice is little bit low. If you could speak louder or take mic.
Okay. This is why I said I don't know how it is. Okay, I am. Is it now? Is it okay?
Bit, but still, sir.
Still, actually, I don't know. Maybe let me connect to my this connect to Wi-Fi of my own mobile. Maybe it will be little okay. Just 1 minute. Is it now a little bit better? I to stop the video. Is it audible now?
Sir, voice level is same. I think, sir, it was not related to network issue. It may be if you could come near to your laptop or speak louder, maybe it may help. But,
okay, let me switch off my video. That will improve. I think audio happens. Switch off video. Yes. I don't know. Can administration can do that one? I think video switch off. If you can do that, it will be. Now is it coming, sir?
Yes, sir. It is audible and clearly sound is there.
Clear sound is there, so I can continue. In the middle, maybe I'll stop my video if required. So anyway,
Maybe
this
participant network is there. Problem is there. Sound is audible, sir.
Okay. So this grid connected and this is a current source. There are two kind of converter. One is voltage source converter, and another one is current source converter. There is some problem with just 1 minute.
Screen is not visible, sir. Screen is not visible. Your voice is coming. No.
Oh, just 1 minute. Save. Okay, stop presenting. And save the screen. See, is it coming now?
Not, sir. It's not visible, sir. Share it once again.
Okay. Is it visible now?
No, sir. PPT is not visible.
Not visible.
No, sir. The screen have been shared. Please open the PPT. It will be visible.
No, PPT I am showing. This is
But
the
it's not-
screen, only PPT.
Sir, once you stop share it and again share it, now do it again. So it will be
1 minute. Share PowerPoint. Okay. Can you see now? Is it okay?
no, no, sir. It's not visible.
I think I should go to Ginger and I'm in a hotel actually. They have this type of internet. I think yes. Now just look at this. Is it visible or not?
Yes, sir.
Yes,
Yes, screen. Yes, sir. It is visible.
Okay.
Fine, sir.
Okay, so I put that network initially. So you told again change to another network. That is not working. So anyway, I try to explain. You try anywhere there is a you are not able to hear. You can ask in the lab. Okay.
Okay, sir.
So here the most important thing that we use a current source inverter for this one, by which there are a lot of challenges. But generally, you know that current source inverter are very robust and a very, very high power application, especially When we have a very high power handling capability, like hot strip mill, rolling mill, and many places we use this current source inverter because of their robustness. So why it is robustness? Because there is a unidirectional current. Whenever there is a unidirectional current, current makes the complete unit a very stabilized one. So when PV is connected to the grid, there is a filter circuit through a transformer, and this is the whole control block. I am not going detail. The control block means what are the things that we should know to control. If you see an inverter, generally we never look the fundamental thing of the inverter. First thing is inverter has a switching frequency, filter has a resonant frequency, and your controller has a sampling frequency. And these three frequencies, they are very important for understanding a system dynamics. So here in this system, we can closely control one, what you required when you synchronize to a grid, a three-phase system when you synchronize to grid, what we do? We see that the phase must be same, the voltage must be same, the phase sequence must be same, and the frequency must be same, or the voltage magnitude. These are the few things we see. Exactly in the solar also, we also try to make like that. Exactly. Cannot feed any power, especially to a three-phase grid. So we have a three-phase PLL, which PLL is a phase lock load. Like I'm not going detail of that. These are the mathematical modelings. And after modeling this one, when you model a simple circuit by using KCL, you can design this one. If you see it, anyway, this modeling, you can, I think, there are few. So if you see this one, when you design a controller, so what we design, whether the system is stable or not after designing, you have a filter, all magnitude you need to design, and then you can find out what is the phase margin, what is the gain margin based on that one. You can use the other way also. There are many Nyquist criteria, many other ways. This controller design is not only a simple this control is design, but what are the constraints after designing the controller? And was that in a current source inverter, there are two switches must be on because the current is very difficult to control. For example, why we have a very high power transmission system, high voltage, not high current? Because breaking current is very difficult, very difficult. For example, like water. In a dam, you can close the water. Like near a dam, if you go to a dam, or hydroelectric power station. So we have a storage of water, and from the storage, you can control anyway. Some water you send for drinking, some water you can give for agriculture, some water you can give for washing, many things you can do. Once water flow in a river, you want to stop in the middle, water will devastate many villages. So similarly, when you have a current source, there must be always a path available to the current. And there are 6 number of switches, and there must be 2 switches, one switch in the upper leg, and another one must be lower leg, minimum 2. So if you make it 3, what you will gain? If you make 3 switches on, like a 120-degree conduction angle, like in a voltage source inverter. So 2 switches are on at a time. So similarly, in this one, 2 switch must be on. If more switches will come, then it will have uncharacteristics or undesired harmonics. So that is why there are six active switches. You can see they operate for 120-degree phase, S1, S2, and there are few null vectors. And when we use this table, then you can find there are the getting signal up during the decoupling. So after that, so in case of a voltage source inverter, generally the DC link voltage we put a constant, but here because it is a current source, so DC link current is put as a current source. So when you can see that the reference current is tracking with this current. Another one is feeding the voltage to the grid after the filter. That also they maintain unity power factor. What is the purpose of unity power factor? It is called utility friendly. Like you have a friend, and after you go and meet him, and some friends are there. Even if you meet him, you don't get some excitation. And that is called utility friendly. Like here, you feed the current and voltage to the grid, and both are they operate at a unity power factor. That means maximum power transfer. At the same time, their ripple content is very low, and if it is operating at a unity power factor, there is no reactive power from the grid. So no power quality problem comes. Then these are the some modulation index MA, and then we have this is the DC link voltage, and these are the current output current. In a 3-phase, you can see all current are 120-degree phase apart from each other, and we are feeding that current to the grid after filter. You can see that it is a sinusoidal current. And also the total harmonic distortion means that pollution in the system. Harmonic means what? This is pollution. Simply like Ganga water. You go to Haridwar or you go to Devprayag. So beautiful Ganga river water. You can drink, you can do directly, you take bath. But as Ganga river flows, but there are many places where the impurities they put into the Ganga river. Actually, Ganga river never became contaminated because Ganga has the, according to research in IIT Kanpur, has the friendly bacteria. So that way, these are also in our power system also, we connect many Xerox machine or many inverters, converters, and many chargers. They draw the non-harmonic, the non-sinusoidal currents, so that creates the harmonic. So harmonic must be controlled. And that way, we can see that these are the filter current and voltage. And when you see this, this is the filter current and this is the filter voltage. And then we tested the performance of the PLL, and the performance of this PLL, you can see that this performance is maintained within one cycle. You can see here below the figure. This all this one is maintained very nicely. It is maintained, and both are. This is connected, and this is very nicely. You can see that in one cycle it connects. And this is our complete. And the conversion technology, you can see that result that both current and voltage, they are tracking very nicely and they are also well maintained. So if you see that there are a lot of challenges in this design, and we have designed this. So if you see a small video, you all can see this video. He is a doctor, now he's a Dr. Jitendra. He stays in Denmark. But when he was feeding the power to the grid, you can see here there is an isolation transformer, and we are feeding the power to the grid. So you can see here. So this is your feeding our power, the grid. You can see that this is a inverter, and this inverter through a interfacing transformer. This is the interfacing transformer connecting to the grid. So we are feeding this power from the solar to the grid. It is possible. So then we have designed, this is a project from USA. We have done with a collaboration with Tennessee Technological University, where if you see our solar system, they develop the power or the voltage. If you will see that 20 volt or 22 volt like that. But the grid is at the level of 440 volt or 111 kV or 33 kV in that level. So how to develop that one? So what we do, we have used the dual active bridge, DAV converter, where the DAV converter can convert this low voltage to the higher voltage. And then connect it to the DC bus, and through DC bus is connected to a complete power system network. And all the solars are connected. That is what it is called the all solar microgrid. This is a small microgrid structure. So this microgrid structure is very nicely which is developed. So if you see this one, this is our the objective of research here. If you see here, the objective is that there is an isolated converter which controls the flow of the power, and then we will model the complete unit. So what we actually designed here? We designed, because complete design is very difficult within specified time, and I had only 3 months to design and develop the complete. So what we did only this part of this one, then later it can be connected to the proper grid. So we used the dual active bridge converter. So like DC-DC converter, if you see, a non-isolated DC-DC converter, if you see, these converters, they could able to develop and they could able to transfer the power only limited range of it. So after this limited range, this power transfer, but limited range of conversion, like you have a 12 volt, you can go up to the 6 times or 5 times maximum. But when you have this dual active bridge converter, you can go to very high power level. So this dual active bridge converter is like a 2 power source. They're connecting through the line inductors. So if you have a source 1 and source 2, and the source 1 and source 2, they are connected through a link, and it is like a source and sink in a complete power system. And like a power system, we have V1, V2, the power transfer is equal to V1, V2 by action sine delta. Exactly this also will act in that similar kind. So the total switching functions we have developed in this way, and this switching function, anyway, this plus, minus are missing in this one, which is some, I don't know why it is coming like this. It was very nicely there. Anyway, so when we control the switches, the first 2 switches are controlled. You can see the power transfer, it depends on the lagging of or the operating voltage waveform of the primary and the secondary one. So this way, if you see this one, we transfer the power when the bridge 1, there are 2 bridges. Let me go to this. There are bridge number 1 and bridge number 2, or high voltage side 1 and side 2. So when these 2 bridges is connected, so if the first bridge is leading from the second, power will flow from port 1 or bridge 1 to bridge 2. If the bridge 2 is leading to bridge 1, power will flow from bridge 2 to bridge 1. This is the beauty of this DAV converter, where voltage, the grid to vehicle to grid is possible. So similarly, if you see here that controlling we are done, we have done this control, and after controlling this one, you can see that the power of the voltage flows from one place to another one, and you can see that it is it is traveling from port one to port two, and but if you see the power, there is a red color that is called reverse power flow. It happen in a given power system also. The reverse power flow, which is very dangerous for our controllers and as well as our power circuit. So this reverse power flow need to be controlled. And this reverse, you can see this is the simulation result. And this reverse power flow, we used then a new technique which is called the extended phase shift. And this phase shift technique, you can see that the reverse power flow portion is reduced here. And after reducing this reverse power flow, this is completely, you can see that this power is, reverse power flow is very minimized and regulated. So this way we control this reverse power flow thing. And then we have a comparison is EPS, and there are two switching methodology we use, and we control that which methodology we can get a better performance and a very high efficiencies that we tested, and they then there are then we did modeling of this one. So what is this? First thing is circuits we developed, and this circuits is modeling by using these equations here. You can see that these are equations, these are the switching functions of the equation. VSC1 is U1, V1, this is what, and VSC2 is U2, these are the switching functions. So these functions, we model a simple equation here, a modeling equation, and these equations are very nicely, they have voltage and current. And those equations we modulate, we try to do by using simulation, and this is a simulation, and how to develop that delay circuit or the circuit we develop in the simulation. After designing this one, then we have averaging, and the average this Fourier function. Then I am not going detail of this mathematics, so you can see in our papers which is published on this one. And then this is a transfer function of this one. Then we have developed, this is the whole control, state space representation of this control. Then this control we put in a closed loop system, like there is a small signal averaging model we did, where there is a small deviation, and this is our small signal model. And this is we implemented with 3 kilowatt charger. And recently we have developed a 3.3 kilowatt charger, and it was initially it was developed a 3 kilowatt charger. And these are the parameter, and put all these parameter, we get a transfer function like this. And after getting this transfer function, nowadays in the MATLAB you can find the stability also and get many the gain margin, phase margin, and PI controller gain also. You can easily get the tuning parameter for that one. And this is the different parameter which is associated. Then when we tuned this parameter, it is very nicely tuned, and you can see that the peak overshoot and many things are we found out from this simulation. After that, we see that whether it is stable or not, it is stable. So after verifying, then this is the complete simulated model we implemented in this simulation. And this is the simulation model, simulation diagram, where the inductor currents and VSC1 and VSC2 and VSC3, all these currents are there. Then we have a simulation result. These are the few simulation results. I am not going. But what is the difference? For example, you are driving in a drive cycle, and suddenly there is a voltage, suddenly your battery voltage increase. So whether your system is controllable or not, because like we have designed just a few days back for IIT Mandi, that 50 volt and 50 ampere current. And when the drone, we put this type of power supply for the drone. When the drone go to high altitude, the voltage comes down. And as soon as voltage comes down, drone comes down. So similarly, when it comes down, again the battery voltage suddenly rises. So those type of technology you cannot control that. But how you can control? We can control by this method. You can see here exactly whatever you are giving the reference power or reference voltage, it is tracking very nicely and according to your requirement. Similarly, if you see here, these are the simulation results. They are the perfect tracking performance. And you can see here there are a lot of this and how our reference is red color, and it is tracking very nicely. When this all solar microgrid is connected with the load, then you can see that you can transfer power from the grid to the battery and battery to the grid, and always it is maintained unity power factor. I will see the result. You see here, when power is feeding from the grid to the battery, it is maintained always unity power factor. And when it is giving back from the battery to the grid, it's just opposite to that unit. This way, you can see that there is a stability in our voltage also. You can see that the DC voltage is stabilized. And there are few simulation results for the current and voltage. I'm not going. All these are the similar result, and we obtain and we read it. Then, if you see, there are a ship engine. In the ship engine, you will have a very high power propulsion system, and then you have sometimes three-phase the generators, and then you have a single-phase generators, and you have a DC-DC batteries, DC-DC power, and solar PV. So many varieties of power, and the AC power, DC power, all batteries, grid, all these things are combined together. You have a simple microgrid, and controlling this microgrid is real challenging sometimes. So how we will control this microgrid? When we see that this type of microgrid control, this type of microgrid control, when we simulate, you can see that battery controls power for to DC link. There is a DC microgrid. DC microgrid maintains always same voltage. So whether the solar power is variable, you should get after the elective breeze, and battery is maybe charging, discharging, that is also should maintain. Phase also the grid should be maintained. This is the challenge in this one. So when we do this one, there are a few the result how the battery voltage varies and how the power. You can see the voltage, input voltage and output voltage always maintain unity power factor. That means it does zero reactive power. And similarly, here also you can see this is the your power voltage and current is maintained. Also DC voltage, and this is our experimental setup where two DAV are connected through the high frequency transformer, and we control this entire thing. And these are the few experimental results of that one. So if you want to know about more about this one, this IEEE transition thing available. So when we go this, what is the new in this one? If you see, there is a direct inverter is there, and you are filtering, then you are feeding to the grid. What is the new? Many times we ask. The new the thing is that the reinvestigation of this one for a low cost system, grid connected inverter system. And then we use some MPPT algorithm, everybody knows this one. So when we use like this, then what is the modeling of the single stage model? That the single stage model, we have an inverter, then a filter, and connecting to the grid. And if you see, these are the equations for this. Okay. Then if you see here, the most important thing is that the this is Just 1 minute, there was some glitches. Hmm. Okay. Sorry, actually, there were some glitches in this. Okay. So, is it audible to everyone?
Yes, sir.
Hello?
Yes, sir. Sir, audible.
Okay, thank you. So,
Sir, audible.
see, this is A grade. So, what is the difference here? When we see a inverter, we connect to the grid. But most of the time, what we do, we just buy an inverter and connect to the grid. When we see this one, there are lot of challenges when we connect to a grid, whether it is a three-phase, whether it is a single phase. In the three-phase system, this grid connected, there are a lot of challenges because of this filter circuit, because of this unidirectional power flow, because of the synchronization. There are a lot of challenges actually. These are the few equations and proper equations are not coming. But what is the filter design? The most important thing is that what is the minimum voltage drop you can get, and minimum reactive power and also damping need to be created. Then robustness according to grid impedance variation and pepper attenuation. These are a very important thing for designing a filter circuit. So L and C can be found out where there will be minimum disturbance during the grid when there is a voltage fluctuation in the grid side. So these are the few PLL technique we use just to estimate the voltage amplitude and frequency and phasing. I told you this is the main component by which you can integrate with the grid. Not that you purchase it and you just connect it. No, there is a requirement of this one. That is why. So there are lot of the designs are needed for PLL. You can see this is a simple PLL structure where we have developed this one, and this is our Opalati system where we simulated. If we see this one, this is we used the Lyapunov stability theory because generally the nonlinear systems are required to actually modify the nonlinear control based of the system. Because the switching systems are like a nonlinear, and if you design a linear controller, most of the time it fails to act. So that is why it is very important thing just to understand what is the so we used many kind of PLL, so modified first order PLL, mixed second order, third order, and moving average. All this PLL we verified. You can see that we have proposed a PLL which is here you can see that there is a lot of overshoot and there is also undershoot. Then there are tracking errors. So many things come. So the proposed system has better the PLL structure. And also here you can see that there are all these PLL are compared, and the proposed PLL can give less overshoot, and they are also as per the results also. They are quickly proposed. You can see that they are very quickly responding to the system, which is a very important thing when there is no inertia in the system. Because in solar system, we do not have inertia. And the inertia is created by our LNC. Sometimes battery storage is inertia also people are giving. But it is very important for all of us to know that this type of inertia can be maintained. Your system is very fast. So similarly, this one is also. So when we connect to a weak grid, like Indian grids are very weak grid. If you go to village, you will find that some houses their lights are glowing very bright. Some houses there is no bright. So there are many kind of the weak grid condition can be arises in our system. But if you see, there is a small voltage take up 30%. So how it is maintained? If you see here, the current goes high. So how this during that period your PLL, they may also, because of the lower voltage, the error may be more. So that time how it will be taken care is given in this one. You can see that this is the complete comparative table of developing this one, and then we have implemented this complete and the performance is studied for this. Then we have put in our IIT partner, before putting anything, we studied the most of the time we try to give very quickly that what is the limitation. For example, you see here, your voltage is very sinusoidal, but current looks at triangular. What is the problem here? This is a solar system. You are feeding a triangular current to the grid. So a lot of power quality problem, many problems will come due to it. And most of the time we never look at it. We just simply buy a solar system, connect to it. So when you see, there are a lot of standards available for the solar system, and there are few harmonic standards by which one can connect the total distortions must be less than 5%. These are the harmonic standards and European standards. So these standards need to be maintained before connecting to any system. And the total voltage harmonic distortion should be 8%, including up to 40th harmonic. So brief description. So we have around 45 solar panel connected to MPPT and storage bank, then power distribution loader, and this is our complete system description. And this system we want to develop, and this complete system we developed in. First thing we did modeling and filter design. After the modeling, this is the modeling of the state space modeling of this one, and this is our controller design. And then we put all this design. You can see here we have used low voltage batteries, which is 2 volt. Why 2 volt? Because the 2 volt battery, like Tesla car, each voltage cell is 2 volt. Because in Tesla car, even if one voltage shorted, the one battery, still the overall performance of the battery will remain constant. Similarly, here also we used the batteries nearly, it is nearly 5-6 years. Still these batteries are working. You can see in the here there is the performance of the voltage and current also. When you see, this is a current which is like a triangular current. And but if you see the volt by controlling this one, you can see that both voltage and current are sinusoidal and in phase. Where it is when there is a full solar system. And then this is our current. But when there is a partial shading or low loading condition, you can see your triangle, the current is not actually sinusoidal. If you see here, there are a lot of harmonic. But when it is a full loaded condition, you can see both the current and voltage are sinusoidal. And similarly, when you have a grid feeding also, when you feed from the battery to the grid, this is the one, senior. So when this DC link charging system, it will get just opposite to this one. So this complete control we design. Then we have developed a hybrid wind solar installation where we have wind turbine solar system, then we have all the thing, and then we have a solar charge. If you see here, there are horizontal axis wind turbine, vertical axis wind turbine, then there are this what you call this solar system and a battery system, and we connect. So this we develop in IIT Patna campus, where it is a portable power unit for the people. So if you see here, this is a simple, a small portable power unit which we tested with this solar system, and this is a 400 watt solar and 201 kilowatt wind turbine. So if you see, we have developed designed many. First design is in Tennessee Technological University, where I have designed a solar microgrid, and it is we developed, and there was no wind clearance, no optimum angle, no structural step, no grass free land. And then there was a lot of problems because of this thing. But next project in Nashville, USA, we developed around 1 megawatt solar, and in this solar unit we have we put this one, and very nice grass free land, very nicely developed this one. And then in the IIT Patna, you can see that all structure, everything is designed by us, and its cost actually this can take a clearance up to 200 kilometer per hour. Wind clearance also there, and grass free, very nice. And you can see that perfectly we designed the grounding system, everything is designed by our students. Then 1 megawatt solar plant we have installed in our IIT Patna, and it is distributed and communicated. At least 40 in association with Desi Power, nearly we connected 40 unit of 1.2 kilowatt power in different stages in the Araria district of Bihar. So he is Mr. Saran, who stays in Switzerland, but he gives a fund for installing and maintaining these village powers. So there are another project we did in the Vaishali district, where 50 houses we provided power supply, and completely we designed with this solar and the diesel generator. And diesel, this is a variable diesel generator, which is very special. Like we have a 5-star AC, so you have very what is that one? There is a controllable. You require how 4 people are there, so you get only that much power. That is called variable speed drive. So this is also variable speed generator. If the 4 houses are on, it will only give that much power. Like our, it is not like our diesel generators. If 150 kilowatt power is your constant speed generators, so they give you 150. Even 2 people are using 150. No, it is. And IoT based communication we completely, right? And another project we have done, the Port Blair Air Force Station, 1 megawatt solar plant. This is the complete design of 1 megawatt solar plant, and developed and tested also. And this whole, you can see that this cabling, and this is a complete earthing pit. You can see that because it is sandy, so we put a lot of earthing pits so that there is no isolation in the earthing pit. So there are few projects we developed for IoT based smart grid and smart home, and this is the complete unit of smart grid system, and it is available. You can see that it is in IIT Patna, and this is we developed. There is a wind turbine, solar controller. They all are connected, and you can see that in Tennessee we developed many such projects. Project at 700 kilowatt, and after that, and you can see here few. Maybe you can push here. We have a horizontal axis, then vertical axis wind turbine, and then it is connected to the. This operated low speed, that operated high speed, and then those generators will collect this, and where the charging circuit. Then This is solar tree. You can see that this solar, wind, all are connected to a as a controller, then connect to the smart load. You can see our smart loads are connected as a in our garden. We put these smart loads. Then complete unit is designed and then monitored properly. Then after we design the laboratory prototype, you can see this all the microgrids are designed laboratory prototype. And then these are local loads. This is Surya Prakash with the faculty in NIT Jamshedpur. Okay. So thank you everyone. Thank you very much. So if you have any question or comments.
Sharing your great knowledge with us. Great topic. Electronic technologies application. If there are any questions, you can may ask. Ready?
Okay, if you don't have any question, you can write me sometime email if you.
Thank you, sir, for giving the great knowledge, sharing the us.
I have one question.
Please.
Yes.
Sir, may I know that which type of generator is most appropriate for vertical axis wind turbine?
Actually, now we use when low power is there, permanent magnet generators are used. Okay. And high power generator, generally we use the permanent magnet synchronous motor. These are the small because 1 kilowatt. They are permanent magnet generator. Okay.
Permanent magnet generator, three-phase generator, sir.
Yes, yes, three-phase generator.
Okay, sir. Okay, thank you.
I was working in G. We used to install 750 kilowatt, 4-5 I have installed. They are permanent magnet synchronous generator. And 500 kilowatt double fed induction generator. We use. So,
Okay, thank you, sir.
so thank you so much, everyone.
Good evening, sir. Am I audible?
Yes.
Yeah, this is Vinay BK from CI Karnataka. You are telling something about MPPT method, sir. So practically, which MPPT algorithm is good for four-wheeler electric vehicle if you are integrating solar panel along with the vehicle? And also, if we are using MPPT method, which converter which is suitable for that particular MPPT algorithm method?
You see, there are different type of converters we use, but generally the conventional is a DC-DC converter. Okay, but I am against to DC-DC converter because when the MPPT tracking we are doing, when there is a partial shading, or when there is somehow two panel out of four array of panel, two panel broken. So your MPPT method doesn't work there. Okay. So most of the time, if you're driving a vehicle, if you see you are going in a road, sometimes there are shadows are there. As soon as the shadow come, whatever your MPPT, whether portable or incremental conduction, whatever, that will not work after that. So that is why it is very important for us. The MPPT method must be like generally low cost MPPT method is P and O method. So simple because all the controller easily it can track. But when you will come to there is a real application, there you need to develop. There are two kind of. One is to find out the local stability, a local global maxima, and global minima. Then only you can track properly. So actually we can do that one. So October observe method is the best. And when you have some kind of little isolated DC-DC converter, okay, like flyway converter, like that, that will give more efficient and more connectivity more properly. That will be good. Non-isolated converter sometimes, so it is malfunctioning will go. This way you can, you need to investigate how actually according to that it is fitting to you.
Thank you, sir.
So anyone want
Any other
to
questions?
want to work in hardware, they are most welcome. And we have a lot of hardware.
Thank you, sir.
Any other question?
Okay.
Oh, no.
So thank you so much, everyone, for joining, and thank you, Navadip sir, for inviting me. Yeah.
Thank you, sir. Dr. Nadeem is here.
Thank you very much.
Your session is so informative. Maybe you are so busy today.
Today, a lot of here Nampet meeting was there, so it took a lot of time. 7:30 actually. So thank you so much.
Okay,
Thank
sir.
you.
Hare Krishna, sir.
Thank you all the participants for attending this class. So I will request you to give the feedback and attendance on the Google form provided by in the chat, also in the WhatsApp. So thank you everyone, and we'll meet again at 6 p.m. tomorrow. Thank you. You can may leave now.